This is the new completely integrated solar tracker control board. You can see the MOSFETs here, the MOSFET driver, of course the Atmega 328 microcontroller, a real-time clock. Actually the magnetic sensor and the tilt sensor are almost too small to see. And here we have the RS485 communication chip. In order to test and program that board, we have also made this pogo board. Here are the pogo pins to contact for in-system programming, and we have the RS485 breakout board, which is connected to the Arduino Uno. All of this is actually an Arduino Uno shield. Here we have motors that are for testing of the MOSFETs and the motor driver, and here we have an FTDI board for serial communication to the computer, and here are some indicator LEDs. And now I pressed the controller board onto the pogo pins and secured it with nuts. This selector switch needs to be set to ICSP. The switch is actually the wrong way around as compared to a jumper, which is usually going into that place, which will give 5 volts for in-system programming. We want to burn the mini-core bootloader for Atmega 328 with external 8 MHz, and the Arduino Uno is configured as an in-system programmer. So you can see that programmer Arduino as ISP. And now I'm going to hit burn bootloader. As I hit burn bootloader, you can see, well, how the bootloader is burned by the indicator LEDs. So we were successful. Now I switched the voltage supply to run, which is supplying 3.3 volts instead of 5 volts to the microcontroller. The 3.3 volts come from the onboard voltage regulator now. In my case, COM6 is for the FTDI serial programmer, which I'm going to use to program the tracker program onto the board. I'm going to upload the latest version of the onboard tracker. You can see the FTDI adapter flashing as the program is uploading. I started the serial monitor of the FTDI on COM6 at 19,200 bauds, and the board is responding. I can also control the motors here in calibration step number 3, for instance by hitting U for up. As I do that, the motor starts running. Now we are in the mode where we have to calibrate the elevation, and consequently the board responds to tilt. In calibration step number 3, we can use a flashlight in order to test the motors and the sensors simultaneously. Here we would usually look for the sun. The serial monitor has plotted the sensor readings. Now I mounted the new board on the tabletop tracker that I used for the development. It's running in fast forward mode now, which is about 40 times as fast in astronomical tracking. But I can also take a flashlight and shine light on the sensor, and it will focus in on that light beam such that the same amount of light goes on all LEDs. When I take the light away, it's going back to astronomical tracking. On the back side of the board, I want to point out the connections. The first thing you will need are those pins for the ICSP programming. Later on you will need the pins for the serial communication. The pins up here are for the sensor. Here we have the connections for motor 1 and motor 2. Here and here are the connections for the power input, 12 to 36 volts. There are some jumper pads. Here we selected that we want to use the LEDs as photodiodes and not connect another sensor. Here we have the selection for the voltage, which is either 5 volts for ICSP or 3.3 volts for running. Here are the pins for the RS485 communication. Oh yes, and here we have to select whether we have the Atmega 328 version P or PB installed. So we want to connect those two pads with a solder bridge. And here there are some extra communication ports, and up here we can connect the wind sensor and also some auxiliary devices. We have brought pretty much all the pins that the Atmega has outside in order to make this board very flexible in use.